All right, so we are working on example 8.11. And note that I need this extra k out here. So what we saw last time, I just forgot to multiply by k right there. So what we're going to do now is I can rewrite this again if I want to. Let me go ahead and pull out any constants. So that would really just be m over k square rooted integral from x naught to x dx over the square root of 2e over k minus x squared. Okay, so again with this is a little bit more of a complicated integral, so I don't know that offhand. So what I would do is I would go ahead and use some of these resources that I'm about to show you. Okay, so let me go to my browser and I will go either to Wolfram Alpha, which maybe you guys have seen, so Wolfram Alpha, and just click on their website, and then you can just put in what you want. You can extend the keyboard, so you can write integral of blah blah blah. So I was putting it in as this way. I had an e there initially so that I knew that that was my energy, but it thought I wanted lowercase e, which is a constant, so I just put in L just for as a placeholder. Okay, so then I got it going, which it's reading it correctly. This is what I want, but it does not give me my answer. So it says try again with Pro, but I don't want to buy anything. Okay, so then what I do is I'll go ahead and Google integral table. Okay, now this first one is literally integraltable.com. Okay, integral-table.com, and I already have it pulled up here where I need to go, but this is what it looks like. Okay, so it's got some basic integrals here. First of all, the very simplistic one here. Okay, and then we have some different ones. We have some squares, then we have some roots. Okay, and that is what we are looking for. So we have the form, if I go back here, we have the form where we have 1 over the square root of something minus x squared. Okay, so this is key, what we're looking for, this minus x squared and this square root. Okay, so what I'll do is I'll go down the list and kind of see what looks like it. And this is going to be the closest one right here, where we have 1 over square root of a squared minus x squared dx. Okay, so this is the integral that we'd use, and a there would be our term here. So if we say that this is equal to a squared, that means that a equals 2e over k square rooted. Okay, so we'll use that form, and so I can go ahead and write my constant out here. Okay, and then I can get this form, so it is equal to an inverse sine x over a. Okay, so sine inverse of x over a, which is this square root here, so 2e over k. Okay, and again this is from x naught to x, and I don't want to bore you with more of the simple calculations going through the x and x naught, but I will go ahead and we'll look at the textbook solution. So this is as far as we're going to go right here. Okay, So let's go back and look at our textbook. So that is going to be where they get this here. Okay, so see how they don't have any steps here. Okay, so you'll have this constant out front, and then our sine inverse of x over the constant, other constants, minus sine inverse of x naught over some constants. Okay, now we know that the particles started at rest at t equals 0. Okay, so that means that our initial kinetic energy is 0. And so our initial potential energy is equal to our total E at that point. Okay, so we can go ahead and solve for E is equal to 1/2 kx naught squared. So then can plug all of that in, and it goes through that a little bit. Okay, so we go ahead and plug E in to these two here, so here and here. Okay. And then they go ahead and solve for their x of t, and so now they have their equation here. Okay. All right, so this one was a little bit complicated, but I just wanted to give you guys another example of how to solve for your function of your position function in terms of time. Okay, and a couple of resources. So again, Wolfram Alpha usually has some pretty good stuff. So if I do that, it might help. Let's see. You always want like the simpler form, because it usually will do it. So let's see, what if I do just that and I don't give any kind of, yeah, so it was those the limits that it didn't like. But again, you can see that it gives you an answer, but the integral table does just as well, and it gives you a lot of them. Okay, you've got logarithms, you've got exponentials, trig functions, and so forth. Okay, so this is a really good resource that I found when I was a student taking some higher level physics courses, and it helped a lot. Okay, all right, so let's go back here and talk about really quick some sources of energy. So we've been talking about kinetic and potential energy, okay, and that's all fine and well. It kind of just sticks in our head like this abstract thing, but it's nice to see these things in action. Okay, so we've got let's start with nuclear energy, okay, which comes from the sun for us, and that is where we have nuclear fusion, and that is producing energy. Okay, and that's really the energy resource for all energy on Earth. Okay, we also have thermal energy. Okay, we have radiant energy, electrical energy, and chemical energy. And each of these has a little description if you want to learn more about them. But this is just to get you guys understanding that a lot of these energies are connected to one another. Okay, so and that we use energy constantly, right? So one other thing I just wanted to kind of leave with you guys is the total world consumption of energy by source. Okay, so most of our energy comes from fossil fuels, and you'll probably have heard that many times already in you guys' learning careers or educational careers. Okay, and the few that are renewables, okay, we have a lot of biomass heat, and then the rest are various other sources of energy. So ideally, I'm not going to preach to you guys, but ideally it would be nice to have renewable energies, right? So that it doesn't just go away when you're done with it. We'd like to, in a way, like recycle the energy, right? Something that's not just going to go away, like wind power, right? Wind isn't just going to stop on Earth. So we need to try, hopefully with engineers' help, get more renewable energies across the world. Anyway, that was just a little bit about energy and types of energy, okay, and what we use in real life. Okay, it's not just kinetic and potential, this, abstract thing. These are real tangible things that we need to, take into consideration. Okay? All right, and with that, I will see you guys on the next week, next videos, okay? If you have any questions, please email me or message me on Canvas. Thanks.